Good afternoon, children. What we have done yesterday in our previous lecture, that is, we have studied about elements, mixtures and compounds. Differences also we have studied. Second chapter we are doing, that is the matter around us, is it pure or not? If we say that it is pure, then it can be an element or it can be a compound. If we talk about element, then we say that it is made up of only one kind of atoms, and all the atoms of one element, they are exactly alike, they are similar in mass, similar in size and similar in density, but they differ from the atom of other element. That is what we have seen yesterday, that we have compared an atom of iron with an atom of silver, and we have seen that all the atoms of iron, they are similar, all the atoms of silver, they are similar, but if we compare the atom of iron with atom of silver, then there is quite a lot of difference. Then what is a compound? It is made up of two or more elements combined together in fixed proportion. We have taken the example of water. Then mixture, two or more things mixed in any proportion, but they do not react with each other, that is mixture. All the properties also we have discussed. Now today we are going to discuss about the physical and chemical changes. Physical and chemical changes. As we all know, children, that there are three states of matter, that is solid, liquid and gas, and this is what? This is the physical state of matter. Now what is a physical change? Physical means related to the physics. As already we are knowing that there are three states of matter, three physical states, solid, liquid and gas, and change of course is there. So let us define first what is a physical change. In a physical change, only the physical properties of the substances changes. Only the physical properties of the substances changes, but no new substance is formed. No new substance is formed. So what is a physical change? Only the physical property of the substances, they change, but no new substance is formed. Just take the example of ice. This ice, it is what? It is solid. When it melts, then what happens? It changes into water. And what is water? It is a liquid. So the physical state has changed from solid to liquid without the formation of new substance. No new substance is found means, if you want to change this water into ice, again you can easily change. How you can change? By this thing, freezing it. Again you can freeze the water and you can get the ice. This will again be a physical change, that is from liquid to solid state, but without formation of new substance. If suppose you have, this is a chalk, if I break it into two, its physics has changed, its size has become smaller, but is there any change in its or you can say chemical composition or any new substances formed? No. So, what type of change is this? This is again a physical change. If I tear this piece of cloth into two, then what happens? The pieces will become smaller and smaller, but it will remain cloth only. So, is there any change in its physical or new substances formed? No. So, this is again a physical change. Now, so many examples are there. If you prepare a solution of common salt, another example, solution of common salt, that is NaCl in water. What happens when you dissolve common salt in water? Common salt is what? Solid. Now, when you dissolve it in water, then it becomes, it does not becomes liquid, but you can say that you have got a solution of salt in water. So, this is again the change in the physics, but no, without formation of new substance. So, this is about the one more example of physical change. Then there are so many examples. If you light the bulb, if you put on the light, then what happens? Bulb, first it was not glowing, but when you have put it on or you have pushed the switch on, then what happens is it starts glowing. Again you put it off, then what will happen? The glow will go away. So, this is a change, but there is no formation of new substance. Breaking of a glass. If you have a glass and if suppose it falls down, then what happens? It breaks into pieces, but that small piece is also, what is it? Glass. Only the physics has changed without formation of new substance. So, this is called a physical change. Now, next is chemical change. What is a chemical change? A chemical change is that in which new substance is formed. New substance is formed. Suppose you have a piece of carbon. Symbol of carbon is C. If you burn it in air, if you heat it in air, or oxygen part of the air is taken by it and it changes into carbon dioxide. So, what kind of change is this? This is a chemical change because a new substance is formed in this, and this new substance has new properties. A change in which a new substance is formed with new properties. Here you see this is carbon, this is solid, this is oxygen, this is gas, and here what we have got is gas. Now we know that oxygen is supporter of gas. This oxygen when it combines with carbon, it forms carbon dioxide, and this carbon dioxide, does it supports burning? No. We use it in fire extinguisher to to extinguish the fire, we can use carbon dioxide. So, the properties have totally changed. This is supporter of oxygen. If you burn something in presence of oxygen, it burns very fast, but carbon dioxide, it is used for extinguishing the fire. So, new substance is formed with new properties. The next is original substance. Original substance loses its properties. Original substance loses its properties. What is the original substance here? Carbon and oxygen. Oxygen is supporter of burning or fire. If you burn anything, then it supports burning. But this is the property, and here the product which is formed, that is carbon dioxide, it extinguishes fire. So, the original substance, it loses its property. Then new substance cannot be converted back into new substance which is formed here cannot be converted back into its original substance. This carbon dioxide, you cannot convert back into carbon and oxygen. If you try to get back oxygen and carbon from this carbon dioxide, then you cannot get back. So, new substance which is formed here, it cannot be converted back into its original substance. Then next is chemical changes, they are irreversible. They are irreversible. Irreversible means you cannot reverse it. Here you can reverse it. Reverse it means you can get ice, you can get water from ice, and again you can get ice from water. So, it is reversible. But here you cannot get back oxygen and carbon from carbon dioxide. So, they are irreversible. One more example I will give you of chemical change, that is rusting of iron. If you expose iron, this is the symbol of iron. If it is exposed in air, then you might have observed that it gets rusted. What has happened here? Iron has combined with oxygen part of air and formed an oxide of iron, and this is brown in color. This is brown in color, and we say that the iron iron particle, they have rusted. Now, this is a chemical change. This iron, it has a property that it will get attracted by magnet. Now, this rust which is formed here out of this, it will not get attracted to magnet. Here it is getting attracted to the magnet, and here it does not get attracted to the magnet. So, what we are saying is a new substance is formed here. This is the oxide of iron, which is totally a new substance which is formed out of iron and oxygen. and this new substance which is formed here, it has some new properties. New properties means it will not get attracted to the magnet, and this is getting attracted to the magnet, and this is irreversible. You cannot get back from this rust, you cannot get back iron and oxygen. So, it is irreversible, you cannot, and properties of the constituent elements, they are lost in the product. The product does not have the property of the constituent element. New substance is formed. So, all these are the this is a physical change, this is a chemical change, and this is the difference in between the physical and chemical change. Here only the physical property changes, but here all the chemical properties only changes. Here no new substance is formed, here a new substance is formed. Here it is a reversible change, and this is irreversible change. You cannot get back the original substance. So, this is all about the physical and chemical change. Now, one more example I will give you, that is burning of magnesium. Burning of magnesium. If you burn magnesium, then Mg, that is magnesium, it combines with oxygen and forms magnesium oxide. When you burn magnesium in the presence of air, then what happens? It forms magnesium oxide. This magnesium oxide, it is totally a new substance, and it does not have the property of neither of magnesium nor of oxygen, and this is an irreversible process. You cannot get back magnesium and oxygen from this magnesium oxide. So, this is all about physical and chemical changes. Now, next topic is solution. What is a solution? You have heard 100 times, children, in this chapter only, that when let us dissolve some sugar or salt in water and you get a solution. If we dissolve sugar in water, we get sugar solution. If we dissolve salt in water, we get a salt solution. Or you can add this water in milk and you get a diluted form of milk, right. So, let us define what is a solution. It is a homogeneous. Homogeneous, I explained it to you yesterday. Homogeneous, that is uniform distribution of two or more of homogeneous mixture of two or more chemically non-reacting substances and composition of these substances can be varied. What is a solution? A homogeneous mixture. I told you yesterday, homogeneous mixture means uniform distribution. If you dissolve salt in water or if you dissolve sugar in water, then you get a homogeneous mixture, means uniform distribution of sugar particle or salt particle in water. It does not happen that the salt or sugar, it settles down at the bottom. Of course, you will have to stir it, but in case of, if suppose you take sand and add sand to that water, then what happens? Even if you stir, then also you will see that sand is lying at the bottom. So, that is a heterogeneous mixture. So, here we are concerned with a homogeneous mixture of two or more chemically non-reacting substances. Chemically non-reacting substances means if you mix these two substances or three substances, then they will not react with each other. And composition of these substances can be varied. Composition of these substances can be varied means if yesterday as I showed you that I can add 1 spoon of sugar, I can add 2 spoon of sugar, I can add 3 spoon of sugar. So, what is happening? Composition is changing. As I add more and more sugar or more and more salt to this, then what will happen? Composition is changing, or you can say that composition can be varied, right. So, this is about the solution. Example you can say, take lemonade. This lemonade all of you are familiar with. You drink this, it is a good drink. It is a mixture of water, sugar, salt and lemon. At your home, your mother might have given you that in the water, what she has added, that is lemon juice, salt and sugar. What is it? It is a solution. If you like more sweet, you can add more sugar. If you like more salt, then you can add more salt. If you like more sour, then you can add more of the lemon juice. So, but all these chemicals, they are not reacting with each other. So, what is it? It is a solution. How we have defined? Homogeneous mixture of 2 or more. Here how many are there? 1, 2, 3 and 4, and they are not reacting. Chemically non-reacting substance, and composition of these substances can be varied. That is your choice depending upon your liking, more sugar or more salt or more of lemon juice, right. So, this is about the solution. Now, next thing is true solution. True solution. If suppose you have water in a container, this is water, and to this water you are adding salt. Suppose these are salt particles. This is a homogeneous mixture. Salt particles. Now, we are talking about what? True solution. What is a true solution? This is a solution of salt in water. In this solution, you cannot see salt particles. They are so small in size that they are not visible to you. You cannot see them. So, that type of solution in which you cannot see these particles or solid particles separated or different from solvent particle, this is called a true solution. A true solution is that in which you cannot distinguish the solvent and solid particle. Now, come to the solute and solvent. What is a solvent and what is a solute? Here, this water which we are taking here, water is solvent and salt is solute. Now, how you can find out which one is solute and which one is solvent? That substance which is present in less quantity, that is called as solute, and that substance which is present in more quantity, that is called as solvent. Always That the quantity of the substance, if it is more, then it will be called as solvent. The quantity of the substance, if it is less, then it will be called as solute. Now, this is about the true solution. Now, one more thing, children, aqueous and non-aqueous solution. Aqueous, what do you understand by the word aqueous, children? All of you must have heard the word aquafina, or if you go for any water activity, then the name is given as aqua, right? So, aqua is related to water. So, come to the two types of solution, that is aqueous solution and non-aqueous solution. Non-aqueous solution. Aqueous solution is that solution in which the solvent is water, or you can say solution in water. Solution in water, it is called as aqueous solution. If the solution is not in water, suppose benzene. What is benzene? This is an organic solvent. Now, I have told you, children, what is solute and what is solvent. Here water is solvent and salt is solute. Here, if the solvent is water, solvent is water, then this type of solution is called as aqueous solution. If the solution, this solvent is not water, in non-aqueous solution, solvent is not water, but any other liquid, but any other liquid other than water. This type of solution is called as non-aqueous solution. For example, benzene. Benzene is an organic solvent, and this benzene, it dissolves many substances. Usually it is used as an organic solvent. So, that type of solution will be called as non-aqueous solution. So, this is about aqueous and non-aqueous solution. Another solvent which is used here is carbon tetrachloride, CCl4. This is carbon tetrachloride. Some of the substances that dissolve in CCl4. Sometimes you take ether also. Ether is also an organic solvent in which many of the substances they dissolve. So, aqueous solution and non-aqueous solution, this is clear to you. Some of the examples also I have given of this. Then types of solution, children. Types of solution. What are the components of solution? Components of solution are solvent and solute. Components of solution. They are what? Solvent and solute. What is a solvent and what is a solute? Just now I have told you. Now we have to study types of solution. What are the types of solution? Solid solutions. Solid solutions, then liquid solutions and gaseous solution. In this case, solute and solvent both are solid. Solid solutions are those solutions in which solvent is also solid and solute is also solid. Example is alloy. What is an alloy, children? In your earlier classes, previous classes, you have studied that when we mix two or more metals and form a substance which has some extra characteristic or property which the metals have, but the substance which is formed here, that is having some extra property, that is called as alloy. It is a homogeneous mixture of two or more metals, right? So alloy, take the example of gold. If you want to make some golden jewelry, then pure gold is 24 carat. But this pure gold, it is very soft, and if the jewelry is made out of this 24 carat gold, then what will happen? That jewelry will break down very quickly or fast. But if you add silver or copper to this gold, usually what happens, the jewelry which are made, they are 22 carat. 22 carat means 2 carat of either silver or copper, it is added. What for? To make it hard. So what is it? 22 carat gold. 22 carat gold, it is what? It is an alloy, or you can say it is a homogeneous mixture of gold and silver. What for this gold or silver is added? Silver and copper is added to gold to increase its hardness, so that the jewelry, it lasts longer. So what is this? It is an alloy, it is a mixture, and it is also called a solution. Solution of what type? Solid solution. Solid solution means solvent is also solid, solute is also solid. What is the solvent in this case? What is more here? Gold. In 22 carat jewelry, what is more here? I told you what is solvent will be that which is in more quantity, and solute will be that which is in less quantity. Here what is in more quantity? Gold. So gold is solvent, and what is in less quantity? That is silver or copper. So silver or copper will be solute, and both are solid, and so it is a mixture or it is a solid solution. What type of solution? Solid solution, in which both the things are solid. So that is about the solid solution. Next, brass is also an alloy of copper and nickel. This stainless steel, out of which we are making the utensils, that is also an alloy of iron and nickel, and some other metal is also mixed in it. So what are these? These are some more examples of solid solution, in which both the things, that is solvent and solute, they are the solid. Now next comes liquid solution. Liquid solution means solvent is liquid and solute is solid. Liquid solution means solvent is liquid and solute is solid. Very common example, sugar solution. Sugar solution, salt solution, water and sugar. Solvent is liquid, solute is solid. So, what kind of solution? Liquid solution. Then gaseous solution. Another example of liquid solution is milk. In milk, so many liquids are there. It is not a simple, or you can say it is not a single liquid, it is not a pure liquid. It is mixture of so many things, right? So, gaseous solution, that is air. Example of gaseous solution. Here, solvent is also gas and solute is also gas, right. So, air is a mixture of so many gases, hydrogen, oxygen, nitrogen, dust particles, so many things are there. Dust particles are of course solid, but so many gases are there, that is carbon dioxide is also there, oxygen, nitrogen, hydrogen, so many are there. So, it is a gaseous solution, solvent is also gas, solute is also gas. So, this is the example of. Now, properties of solutions.